In this video, we will explore exponential and logarithmic equations. In solving exponential equations, let us consider these three cases. The first case, if they have the same basis. If a to the x is equal to a to the y, then x is equal to y. Since they have the same basis, these two expressions are equal only if the powers are equal. The second case is the different bases. If a to the x is equal to b to the y, then we can be able to get for the unknown variable, let's say x, by taking log or len of both sides. And then for the third case, if there's a one-term constant, like if a to the x is equal to y, so y is a constant here, so we can be able to solve for the unknown variable x if we change this exponential to this log form. So let us solve the first equation. The first equation is 4 to the 2x minus 1 is equal to a to the x plus 3. So here, if you will analyze this in these three cases, this first example will follow the first case, which is same basis. Even though we can see here that the bases are 4 and 8, but in 4 and 8, we can change these two numbers into base 2. So this 4 can be written as 2 squared, and this 8 can be written as a 2 cubed. So we will change with the base 2. So we have 2 squared to the power 2x minus 1 and a 2 cubed to the power of x plus 3. Now in this equation, so this is power raised to power. So what we're going to do is to multiply the powers. So the left side will be given as 2 to the 4x minus 2, and then the right side will be 2 to the 3x plus 9. So now these two expressions, since they now have the same base, this is equal only if the powers are equal. So we will take the powers. 4x minus 2 must be equal to 3x plus 9. So now this equation is a linear equation, and in solving linear equation, we have to move all the x term on one side and all the constant terms on the other side. So we will get 4x minus 3x, and then 9 plus 2, we will get x is equal to 9. So this is the solution for the given equation. And checking is not required here since we have an exponential equation. And as we know, the domain of exponential equation is all real numbers, and 11 is a real number. But from your side, if you want to know if your answer is correct and you don't have any mistake in the solution, you can substitute this 11 in this given x. So the left side must be equal to the right side to be able to know that 11 is a solution of that equation. Now for the second equation, so we have 3 to the 5x divided by 9 is equal to 3 to the x squared plus 2. So in this equation, this will fall in case 1, wherein we can write with the same base. Because the bases that we can see here are 3, 9, and 3, and we can write all of this with the base 3. So we will copy the numerator, and the denominator, which is 9, can be written as 3 squared. So we will get 3 to the 5x divided by 3 squared is equal to 3 to the x squared plus 2. And then after that, this left side expression, since they have the same basis, what we're going to do is when we are dividing with the same base, we will subtract the powers. So the left side will be 3 to the 5x minus 2, then equal to, just copy the right side. And now in this equation, since they now have the same basis, so this equation is equal only if the powers are equal. So we would just took out the power. So 5x minus 2 is equal to x squared plus 2. So this equation is a quadratic equation, and as we know, when solving quadratic equation, we have to equate to 0. So equating this equation to 0, we will get x squared, then move this 5x on the other side, and move this negative 2 on the other side. So we will get x squared minus 5x plus 4, because 2 plus 2 is equal to 4. Now, factoring this quadratic equation, we can get the factors x minus 1 and x minus 4 equal to 0. And make sure once you factor them, so you can multiply this to make sure that the product is correct. Now, these two equate both of this to 0 to get x is equal to 1 and x equal to 4. So since there is no, we cannot see any restriction in this exponential equation, so we can say this 1 and 4 are solutions if there's no mistakes in our solution here. Or if you want, you can put 1 in the given and make sure that they are equal, and put also 4 in the given and make sure that they are equal. And I'm sure this 1 and 4 are solutions. So we can back our final answer. Now for the last example of exponential equation, so we have 5 to the x minus 2 is equal to 3 to the 3x plus 2. So here, as we can see here, this fall on the cases with different bases. So in bases 5 and 3, we cannot write this with the same base. So what we're going to do here is we have to take the log of both sides. So taking the log of both sides, so we will have log of 5 to the x minus 2 equal to log of 3 to the 3x plus 2. So the idea of taking the log of both sides is if the unknown variable or the x is in the power, the only way to put this as a coefficient is to have a log in these two. So that's why we took log of both sides. So now, since we already have the log on this 5 to the x minus 2, we can now apply the power property by bringing this power x minus 2 as a coefficient of this log. So we will have x minus 2 times the log of 5. And take note, this log of 5 should be multiplied to x minus 2. That's why you have to put parentheses here. So same as the right side. This 3x plus 2 will be multiplied to the log of 3. So you will also put parentheses here. Then after that, let us open the bracket since we're solving for x here. So the left side will be log 5 times x, which is x log 5, and then minus 2 log 5 equal to 3x log 3, and then plus 2 log 3. Then after that, I highlighted these two terms because these two terms are with x term. So meaning you have to isolate this on one side or move all this in one side and no x term on the other side. So we will get this. And I still highlighted the x because this x is already on one side, but it is in these two terms. So what we're going to do is we have to factor out or isolate this x. So factoring out x, so the other factor is this, which is equal to this right side of the equation. Now to be able to solve for x, you have to divide both sides by this binomial here, by this expression. So the value of x will be copying the right side divided by the coefficient of x. So you will just copy this in the denominator. So this is the value of x. And to be able to check if your answer is correct or there's no mistake in your solution, what you can do is you can put this in calculator and try to approximate that and substitute in the given and make sure that they are equal or approximately equal. But checking is not required here in exponential equation. Now, in solving logarithmic equations, there are two cases. So the first one is if they have the same basis. So for example, if log of x to the base a is equal to log of y to the base a, so since these two logs are with the same basis, so they're equal only if x is equal to y. So that is if there's only one log on the left and only one log on the right side. But if there are two logarithms on the left side and one log on the other side, what you have to do here is to write this first in one logarithm. And then once it is already in one logarithm, then you can apply this. And then the other case, if one term is a constant, for example, I have log of x with the base a is equal to y, and y is a constant here, and you're looking for x, so all you have to do is to change this log into exponential form, which is a to the y is equal to x. So you can get the unknown variable x. So let us try to solve examples of this logarithmic equation. So for the first equation is log base 3 of 4x minus 7 is equal to 2. So this example is with the second case because there's only one log on the left and a constant on the right side. So what you're going to do is you can change this log to exponential form, which is, but make sure that the coefficient of log here is only 1. So we have 3 to the power 2. So 3 to the power 2 is equal to 4x minus 7. And this is a linear equation. So we have to isolate the x term. So move this negative 7 along with this 3 squared. So we will have 4x is equal to 9 plus 7. 3 squared is 9. Then moving negative 7, it will be plus 7. And then from this equation, we will get 4x is equal to 16. And then dividing both sides by 4. So x is equal to 4. So now, since this is a logarithmic equation and the domain of logarithmic function is the expression here must be greater than 0, so checking is required for every logarithmic equation. So let us try checking when x is equal to 4. So you will substitute 4 in x of the given equation. So we will have log base 3 of 4 times 4 minus 7 is it equal to 2. So if you will simplify the left side, so you will get 2 is equal to 2. So it means to say the solution for this equation is x equal to 4. So you have to accept this value. So that is a solution. Now for the second logarithmic equation, so we can see here that there are two logarithms on one side and a constant on the other side. So the first thing to do is we have to write this as a single logarithm, and we can only do this by applying the quotient property. It is a quotient property because this is minus. This is a difference of logarithm. So difference of logarithm is log of the quotient. So let us change this to single log as log base 2 of 5x minus 20 divided by x minus 1. So this logarithm on one side and then constant on the other side. So we can solve for x here by changing this log to exponential form so that we can get rid of this log. So if we are going to change this to exponential form, so we will get this expression 5x minus 20 divided by x minus 1 is equal to 2 power 3. So that's our equation. And this equation is a rational equation. And to solve a rational equation, we can cross multiply this. So in cross multiplying, so we will have 2 cubed, which is equal to 8, multiplied to x minus 1. So we will get 8 times x minus 1 is equal to 5x minus 20 multiplied by 1. So the right side is 5x minus 20. And now as we can see here, this is a linear equation. And to solve for a linear equation, let's open the bracket here. So it will give us 8x minus 8 is equal to 5x minus 20. And then moving all the x term on one side and no x on the other side. So we will get 8x minus 5x is equal to negative 20 plus 8. And then from this equation, we will get the left side as 3x, then equal to a negative 12. So dividing both sides by 3, we will get x equal to a negative 4. Now, since this is a logarithmic equation, we have to check. Checking is required here. So let us substitute negative 4 in x of the given. So we will get log base 2 of 5 times negative 4 minus 20. I just substituted on the first term, and you will notice here that this expression is already negative 40. So log of a negative number is always undefined. So I will not continue anymore on the second term or in this right side. So what I'm going to do here is I have to reject this value because it's undefined. You cannot prove that they are equal. So it means to say the solution of this equation is empty or no solution. So the next example of logarithmic equation is this given, and as we can see here, there are two ln on the left side and one ln on the other side. So it is okay if we would just keep this ln of x on the other side And on the left side, just make sure that we will write this as a single logarithm. So since this is a minus or difference of len, so this is a quotient property, which is len of x plus 6 divided by x minus 4 equal to the right side, which is len of x. And now this 2 len, so there's only one len on the other side and len on the right side. So it means to say this equation is equal only if these two expressions are equal. So we now have x plus 6 divided by x minus 4 equal to x, which is a rational equation. And to solve for this rational equation, so we are going to cross multiply. So in cross multiplying, so we will multiply x by x minus 4 and x plus 6 by 1. So we will get this equation. And as we can see here, if you will expand the left side, this equation is a quadratic equation and we need to equate to 0. So as we expand this or multiply this x to x minus 4, let us equate to 0. So we will get x squared minus 4x, and then moving x on the left side, we will have minus x, and moving 6 on the right side, on the left side, we will get minus 6. Now simplifying this is x squared minus 5x minus 6 equal to 0. And then factoring this quadratic equation, we will get the factors x minus 6 and x plus 1 as the factors. But make sure that the product is equal to this polynomial. So now, if you will equate this x minus 6 to 0 and x plus 1 to 0, we will get the two values, which are 6 and a minus 1. And since this is a logarithmic equation, checking is required to show. So first, when x is 6, and substituting the 6 in the given, so we will get len 12 minus len 2 is equal to 6. If you will evaluate the left side, this is len 6 is also equal to the right side, which is len 6. Means this x, which is equal to 6, we have to accept this as a solution. And then for x equal to minus 1, so let us substitute again this minus 1 in the given. So we will get this. So len of 5 and then minus len of negative 5. As you can see here, the second term is undefined and the right side is also undefined. So it means to say we cannot prove this that they are equal. So we can say that this negative 1 as the value of x, we have to reject this as a solution. So therefore, the only solution of this logarithmic equation is x equal to 6. Now for the last part is a real life application. So the first application, so let us read. If 3,000 Qatar riyals is deposited in a savings account, paying 3% a year compounded continuously, how much will you have in the account in 7 years? Round off the answer in two decimal places. So in a problem with a compound continuous interest, so we are going to use or always use the formula A, which is equal to P e to the RT. A is the amount of the money after the interest, and P is the principal amount or the initial money deposited, and E is the Euler's number, which is approximately equal to 2.721, and then R is the rate or the percentage, and T is number of years. So here in the given, I already put this in colored according to this formula. This P is the principal amount, which is 3,000, and this 3% here is for the rate, and we can write this 3% as 0.03, and the T here is this red, which is 7 years. So the question here is, how much will you have? So meaning, what is this final amount? So following this formula, and you have to memorize this, we will have A, which is equal to 3,000, E to the power 0.03 times 7, and then you would just put this in calculator, and the answer into decimal places will be 3,701.03 Qatar riyals. So this is the answer for this question number 1. And then this question number 2, since this problem is about compounded continuously interest again, So we're going to use the same formula. And as you can see here, I already put a color in according to this formula. So this 5,000 is the principal amount. This 4% here is the rate, interest. And this red here is how many years, meaning this t is unknown. And uh, how much will it take for the amount to grow to double? So this final amount should be double of this initial amount. So your money deposited is 5,000, and if you want to make it double, so meaning it should be 10,000. So the A here is the double of 5,000, which is 10,000. So if you will substitute in the formula, so A is 10,000, B is 5,000, then E to the power 0.04 because of this 4% times t. Since this equation is an exponential equation and the unknown is in the power, so meaning we can change this into log form. But before doing that, we have to make sure that the coefficient of this exponential e to the power 0.04t is 1. So we need to get rid of this 5,000. So what we're going to do here is to divide both sides by 5,000. So the left side will be equal to 2 and equal to e to the 0.04t. Now it's ready to change to logarithmic form by getting log base e, or we can write as len of 2 is equal to 0.04t. And then to solve for t, if you cannot understand this part, so try to write log of 2 to the base e is equal to this, and we know that log to the base e is len. So now if in this equation, if we are solving for t, you have to divide both sides by 0.04. So you will get len of 2 divided by 0.04, which is approximately 17 years. As you can see here, the required final answer must be rounded off to the nearest year. So you can try this in calculator and you will round off to 17. So t is approximately 17 years.